Hello grade 10s. Alright, I'm going to make a video for our difference of squares lesson. Before I get into it, I'm going to hit you guys with a joke. Okay, so yesterday my wife, she was asking for some lipstick. I accidentally gave her a glue stick instead. She's still not talking to me. I'll assume that you're laughing in the background. Okay, now on to our lesson. Difference of squares. This is our second way of factoring. Our first way was common factoring, and that's what we were working on in our previous lesson. Now, with all of our factoring questions, we're going to always try to common factor first. If it doesn't work out, then we'll move on to one of our other factoring methods. So, in the title here, difference, that means subtraction of squares. So anything that is squared, for example, 8 squared is 64, or we could have an x squared, we could have, any squared number or squared variable. Okay? And there's always going to be two terms. Okay, so you look at these 6 examples, there is 2 terms in all of them, and we're going to go through them one at a time. So our first one, I'm going to make up a word here. Square rootable. Can you square root these terms? If you can do it, then we've got ourselves a difference of squares question here. Okay, so can you square root x squared? Yes, you could get an x. Can you square root 36? Well, the square root of 36, we get 6. So yeah, this one's going to work out. So this actually factors pretty easily once we can kind of identify what type of factoring it is. So, first thing we're going to do is we're going to break up that x squared so that there's an x in front at the beginning of each set of brackets. The next thing we're going to do is put a plus and minus. Okay, it's always going to follow this kind of step or these routines here. Lastly, the square root of 36 is 6. So I'm going to add 6 and I'm going to minus 6. So x squared minus 6 using our difference of squares factoring method is going to be x plus 6 and x minus 6. Now, just like before with common factoring, we can always double check. Okay, so we can check by expanding. So I'm going to show using our FOIL method here. So in FOIL, we multiply our first by our first. So that's x squared, our first by our outsides. So x times negative 6 is negative 6x. Our insides, which is plus 6x. And minus 36. Okay, so FOIL was first, outside, inside, and last. Okay, and you can notice here that those two are going to cancel each other out. So if you have a minus 6x plus 6x, you have 0x. And we're back to where we started. Okay, so our factoring and expanding, they work hand in hand. Okay, so our first example of a difference of squares binomial, so 2 terms. Our next one here, can we square root 25? Yes. Can we square root 64? Yes. Is there a minus in the middle? Yes. So this one's going to work out. So, just like before, it's going to factor into 2 brackets. We're going to have a plus and a minus there. Now if we square root 25 x squared, square root of 25 is 5. The square root of x squared is x. We're going to have a 5x in the front of both sets of brackets. Now the square root of 64, if you punch that in your calculator, you'll get 8. So it'll be 5x plus 8. 5x minus 8. Now if I wanted to, I could use FOIL to expand to get back to our original equation here, and that would work out. So 5x times 5x will give us 25x squared, we would keep going from there, and it would end up matching our original expression here. Okay, let's go to the third one. Can I square root x squared? Yes. Can I square root 9? Yes. Is there a minus in the middle? No. So this one, not factorable. And looking at this, there's no common factor as well. So there's nothing, no number we can take out of those two terms. So that one's done. Don't even worry about it. Let's look at this one here. Can I square root 2 or negative 2? No. Can I square root 8? No. Is there a minus in the middle? No. This looks again like it's not factorable, but if we go back to our first way of factoring, we can common factor. So here, if I take out a common factor, which in this case, we can take out a 2 or a negative 2, let's see what happens. So if I divide a negative 2 out of the first term, we would just have x squared. If I divide out a negative 2 from 8, we get negative 4. Now, if I double check quickly, negative 2 times x squared is negative 2x squared. Negative 2 times negative 4 is positive 8. We're still good here, okay? So we haven't changed the value of this expression. From here, this is a difference of squares binomial, okay? So we can square root x squared, we can square root 4, there's a minus in the middle, so we'll write out that negative 2. We'll put our plus and our minus. The square root of x squared is x, the square root of 4 is 2. So we have x plus 2 and x minus 2. All right, let's look at the next one. Kind of similar to this one here. Can I square root 5 or negative 45 and get a whole number? Because that's kind of what we're looking for here. In this one, you can square root those numbers, but you're not getting a whole number, and you actually can't square root a negative, so you have to get rid of that negative. So we can't do that here, but we can common factor. So looking at 5 and 45, let's list all of the multiples here and see what we can take out. So if I look at this here for 5, how many ways can we get 5? Just 1 times 5, that's it. How many ways can we get 45? We got 1 times 45, 2 doesn't work, 3 times 15 works, 4 doesn't work, 5 times 9 works, 10 doesn't work, 11 doesn't work, 12 doesn't work, 13 doesn't work, 14, 15's here. That's our whole list. Okay, so we listed out all of the factors for 5 and 45. The biggest number in both is a 5, so that's how I know I can common factor it out. So if I take out a 5, if I divide this by 5, I'm left with x squared. If I divide this by 5, I'm left with minus 9. Kind of like this one. This is now a difference of squares binomial. So we're going to have 5. We'll set up our 2 brackets with a plus and a minus. The square root of x is x. The square root of 9 is 3. We're all done. All right, last one. Kind of fancy looking here because we've got 2 different variables in it. So let's take a look. Can you square root 64? Yes. Can you square root x squared? Yes. Can you square root 16? Yes. And can you square root y squared? Yes. So this one looks messy, but we can actually go right to the answer here. We'll set up our 2 brackets with the plus and the minus. The square root of 64 is 8. The square root of x is x. So we have an 8x. At the start here, the square root of 16 is 4. The square root of y squared is y. So we have plus 4y and minus 4y. And for all of these that are factorable, so all except C, if we multiply it out using FOIL, which we learned on the first day of this chapter, we should be able to get back to our original expression. So hopefully we can start to identify these. They're not too bad if you can figure out which way of factoring you're going to need to use. So first off, we always look for our common factoring. We could common factor in these two, and then sometimes you have to move on to our second factoring method, called the difference of squares. All right, send me some questions if you have some. More corny jokes coming in future videos.